Hi, I'm Ethan Lindstrom. I'm an aerospace engineer, and I was in charge of making the start function work and also working on the tables. So for the start function, basically you have to input number of players, 3, then click start. Then from there you can see that there's 3 players, so this works. From there, if you want to input a value, let's say we roll this value here, then you can input into threes, for example. You get the points tally up. It will automatically switch to player 2. Then you can choose where the points go to again and again. Of course, you'd want to re-roll for each player. But then if you want to go and you accidentally click on threes again for player 1, it will display already to let you know that you've already played that and you need to choose somewhere else to put the points. In terms of the program, for the start function here, it checks to see what value inputted for the how many players. It will first start out with having an array of 3 by 14. So there will be 2 columns meant for player 1 and 2 because that's the minimum amount of players. And then for every additional player, it will add another column. In terms of the how each buttons are linked, basically each of the buttons are linked to a different scoring criteria. So for the buttons, it will check for each of them to see what the total amount of ones, twos, threes, fours are. And you can find them here in the uppers function. For each and every button press, it will also add to the player count. It'll switch the player being played. And if it's on the final player, it'll switch back to 1 and then add to the round number. And if it has already been played, it would just display an error letting you know that you've already played it. So each of these buttons work the same way. For 4 and 3 of a kind, there's also its own function over here to check. For the uppers, it just tells the amount of 1s, 2s, 3s, 4s, 5s, 6s there are. For the lowers, it checks for certain scoring criteria. If it's there, it'll give a certain value for the score, or if there's none, it'll just give 0. Once the score reaches 13, once it switches over to 14, then it will display the total score. And using that total score, you can figure out who has won the game. So this is what I did for the program. Thank you very much for listening.
Hello, my name is Vincent DeMardo. I'm currently a second-year civil engineering student, and the parts that I contributed to the project were the dice rolling generator and the instructions and scoring. So I'll start by going over our instruction and scoring tabs. As you can see on the main screen, you have the game and then your instructions. So I wrote the instructions. Our game is Yahtzee, so we just have the typical Yahtzee rules here. And then the scoring, there's just a scoring image that shows you the types of scores you can get in Yahtzee. And then back here, we have the instructions and scoring buttons, which when you run the code, will open up the instructions and scoring tabs. As you can see, if you press the instructions button, it'll take you to the instructions. And then the same goes for the scoring. It'll take you to the same scoring page. Okay, so here are the callbacks for those 2 buttons on the game screen. Here we have the instructions button pushed, and basically we just use a simple open function, and then it opens the instructions app. And then Jesus added the sounds, so we have a clicking sound for when you press the button. And it's the same for the scoring button. You press the button and you get the open scoring app with the sound. So I'll quickly demonstrate the dice rolling. Basically, all you have to do is press the roll dice button, and then you get the dice. Press one there, press roll dice button again, you get a new set of dice. Here is the function for our dice rolling. Basically, we set each dice with a dice value. So for like the first dice, you have dice value 1, and then it equals a random number generator 1 through 6. So basically, we have 5 dice, as Yahtzee calls for, and each one will be randomly generated a number 1 through 6. And then we put it into an array with app.dicevalues1. Part of the function here is how we get the dice values to match up with the correct image that shows the correct value of the dice. So here we have that same array we just used, app.dicevalues, and then we index it with 1, which basically just would be the first dice value. So if it equals 1, then we're going to get the dice image that shows 1, and so on and so forth. We have, if it equals 2, you get an image that shows dice 2. And it's the same for all 5 dice. Basically, we just change the number of the index so that each dice has the correct image that matches the value that it is randomly generated. So another important aspect of Yahtzee is that you get to have keepers, meaning when you roll your 5 dice, you could choose to keep some of the dice and only re-roll others. So the way that we added this into our game was by having a function where if you click on the dice images and then roll, these will change now and these will not. So if I click on the 1 and 3 and re-roll, now I get different values and these ones all stay the same. And here is the code for that function. Basically, if you press on the dice image, you're going to keep the same value that was already there. So we have this if statement, which the dice count is just the number of rolls. So if it's greater than 0 rolls and less than 3, then if you press the image, it'll just stay the same, while the other ones are still able to change.
Hello, my name is Jesus Cortez. I'm a civil engineering major, and this part of the video, I'm going to be explaining how the game works, the code system that we did for the sound, and the things speak into the game. So we first start off by inputting the number of players that we want. In this case, I'm going to choose 2. Click start, and then we can see that we have the table scores right here with the players, the player number, roll dice, and the number of rolls that we have left. So player 1 rolls the dice, and so we have 5s as the highest. And if we want to keep these 4, but just re-roll this one, we're going to click on it, and then we see this image. That means that we can re-roll the dice. So we click it, and then we have all 5s. So that's basically the highest I can get, at least for this turn. And then we just click on 5s, and then once you click on it, it's gonna automatically fill up the score that you got, and then switch to the player turn, which is player number 2 this time. And same thing, you click roll dice, the highest is 6, and I want to keep it, so I just click on all the dice, we roll, and same thing. And since we have no more rolls left, the highest one that I have is 6, and so I click on 6s, and then it switches to player 1 again. And then you keep on going until all the tables are filled up, and whoever has the highest score wins. And for the sound, we just we implemented a code, which is the sound and the sample frequency. We wanted to read whatever audio that we downloaded, and for the buttons, we chose a different audio, which is this one right here. And in order for it to work, you have to download the audios and save them in the same folder as all the images and the game, which would be the MATLAB one, because if not, it's not going to be able to read it. And for the ThinkSpeak, since we didn't have enough time to implement the code and for it to work, I'm just going to demonstrate how it would work. And we can see that we have the channel ID, the write key, and the read key, which we got from the channel that we created. And the way it would work is once you click a certain button and get a certain score, it's going to send it to this graph right here and create a chart. and as well as in order for it to the other player receive the score and be able to see and basically play in two different devices.